We have just spent some time learning about what a random variable is, and we've learned how to create a probability model. Now what I want to do is look at what happens when we have more than one random variable. So either the same random variable more than once, which means an event is occurring more than once, or two separate random variables, each with their own mean and standard deviation. So before we begin combining random variables, let's see where we're starting. I have a dice game, and I get 0 points for rolling a 1, 2, or 3. And so that means I'm going to put my outcomes here, or outcomes is the same as x, and then I'm going to put each probability here. So my outcome is that I get 0 points, so that's the x, for rolling a 1, 2, or 3. Now I know that there are 6 sides of a dice, so 1, 2, or 3 is half of them, 3 divided by 6. Then I'm going to look at my next option. I get 5 points if I roll a 4 or 5. And remember, that would be 2 out of 6, or 1/3. So I'm just going to put several 3s because I want to be as precise as possible. And I get 50 points if I roll a 6, so that's 1 divided by 6, which is 0.1666 repeating, and at the end I'm going to stick a 7 because of course we would round that last digit up. Now I'm going to use StatCrunch to find the mean, variance, and standard deviation, and then look at what happens when this changes. So just as I did before, stat calculators custom, values in x, weights in the probability that x is x. And so notice I have a mean of 10. Now why does it round up here at the end? Well, that's because I didn't use precise values here, and that's okay. So I have a mean of 10 and a standard deviation of 18.02. And if I want to be more precise, I can do 0.333333 and put some more 3s and 0.166666667, and then I can refresh, and that makes me feel a little bit happier because now the mean is 10 and the standard deviation 18.027756. How would I find the variance? Because notice I'm asked to find the mean, variance, and standard deviation. Well, I would take this value, the standard deviation, and sorry about that, standard deviation right here, and I would square it, and that would give me the variance. So now what I want to do is I want to see what happens if I double each point value. So I'm just going to I'm not going to delete any of the other ones. I'm just going to make a new area here, and x is going to be 0 points for 1, 2, 3 because that would be doubling it, 10 points for 4 or 5, and 100 points if I roll a 6. And so I want to find exactly what I did before, so I'm going to go to Stat, Calculators, Custom. Now I can go ahead and put my original one up there if we still want to see x and the probability that x is x. So this is what I started with previously. And if I go to Stat, Calculators, Normal, or sorry, Custom, and now I'm going to choose my second x. I probably should have labeled that a little bit differently, but I'm using the same probabilities. And really what I want to do is I want to compare the mean of 10 to now the mean of 20, and the standard deviation of 18 to the standard deviation of 36. And what I notice is when I doubled all of my values, that doubled the mean and it doubled the standard deviation. So my summary is that if I multiply the value of a random variable by a constant, the mean and standard deviation are also multiplied by that constant, as we can see here. So now let's take a look at what happens if I add 5 to each point value. So this was when I multiplied by 2. So this one I'm just going to say x plus 5. So I still have my original mean and standard deviation below. Now I'm going to add 5 to each point value, so that makes it 5.0 plus 5. 5 plus 5 is 10, so again I'm adding from the original of 5. and then 50 plus 5 is 55. And I'm going to do the same thing again, stat calculators custom, and this time x is x plus 5, and my weights are still the probabilities, and I'm going to compute. And again, I am now comparing 15 to 10, so it looks like my mean increased by 5, but my standard deviation did not change. So the rule of thumb there is if I'm adding a constant or subtracting, the mean will shift by that constant, but the standard deviation will not change. So we've used StatCrunch to help us to determine what happens if I have just one random variable and I increase it by a certain amount or multiply it by a certain amount. And those should look familiar to you because we've looked at these before a few chapters ago. But now I want to look at something that maybe we haven't talked about in as much detail, which is what happens when I adjust the game by playing twice. So if I roll twice and I'm finding the sum of my results, which of course means I'm adding my results, then what will happen, again using my original points, what can I expect to happen? So again, I've copied at the top just so that we don't have to try to remember what our mean and standard deviation were originally. So this was for the original game. And when I'm playing twice, it essentially means let x be the outcome of the first time I played and let y be the outcome of the second time I played. And now I'm just taking the expected value of the sum of those random variables. And all that means is I'm going to take the expected value of each game and add them together. So if I expect when I play the first time for my point value to be 10, and I expect the second time I play for my point value to be 10, then I'm expecting a total of 20 in my two games. Now, unfortunately, it's not as easy if I want to find the variance or standard deviation. So we know that, remember, the standard deviation, if I square it, becomes the variance. So I have to take the standard deviation squared to get a variance. So notice what I'm doing here is I'm trying to find the variance of x and y, because I can't just take the standard deviation of x and the standard deviation of y and add them together. It doesn't work like that. We can only do calculations with the variance. So I'm going to find the variance of x, which means I have to take this number squared, and that would be the variance. And I'm going to take the variance of y, and so notice that's what I've done here is just recopy these numbers. And when I square those, I get 325 plus 325, so my variance is 650. But I don't want the variance, I want the standard deviation. And so the standard deviation is the square root of the variance. And so this is my standard deviation. So my mean is 20, and my standard deviation is 25.495. So now let's switch it up again. Now I'm not playing twice. I'm playing twice, but I'm playing against somebody else. So one person's playing, the other person's playing. So now I'm not finding the sum, I'm finding the difference of our two scores. So what can we expect to happen? Well, again, we have our original values here for our mean and standard deviation. And the mean of the difference of two random variables is the difference of the means. So just like I did before, when I added x plus y, now I'm saying let's subtract. So the first time I expect 10, the second time I expect 10. If I'm finding the difference, 10 minus 10 is 0, which means I expect the difference of my score and my opponent's score to be 0, which makes sense because we're both expecting 10, so we're not expecting us to get a difference of our point value. Now, where it gets crazy is when we're talking about the variance. So as you can see down here, if I'm finding the variance of x minus y, that should be a minus, it really is still plus here. So the standard deviation of x plus the standard deviation of y because we always add variances. So we never subtract variance, we never deal with the standard deviation. I'm always going to add variances. And so here I have the variance of x minus y is still me adding those together to get a variance of 650. And again, the standard deviation is the square root. And notice that's the same difference as before, or the same standard deviation as before. So that is still the standard deviation, whether it's the sum or difference. So a lot of people really struggle with that. They say, well, that doesn't make sense. If I'm subtracting, why am I not subtracting? But remember, variance or standard deviation, all of those things are a measure of spread. So in the example where I added my two scores, which was one of the first examples we did, I'm going to score in the interval of 0 to 100, because it could be that if I have a sum of 0, that I scored 0 in each game, and the highest I could get is if I scored 50 in each game. And so my value will be between 0 and 100. That has a spread of 100. In the example where I subtract my two scores, I'm going to score the very lowest I could get is if I got 0 the first time and 50 the second time. So 0 minus 50 is negative 50. And the very highest I could get is if I got 50 the first time minus 0 the second time, which gives me 50. And notice the spread between negative and 50 is still 100. It's 100 either way. So the spread of the scores is the same. And so if we subtracted variances, we would end up with an incorrect value. So let's do some practice in combining random variables. First, we're looking at a question where we have Statsville City Hall. 1,000 citizens who are very active in their city on any day. You can expect several calls from citizens on a typical day. 400 call the office once, and right away I'm just going to look at the fact that there are 1,000 citizens and 400 residents, so that's 40%. 200 or 20% call twice, 100 or 10% call 3 times, and the rest do not call. So if there's 40% plus 20% plus 10%, that's 70%. We know it has to add up to 100%, so that's 30% that don't call at all. To find the expected value, I'm going to, and again, I just use StatCrunch, so I did my probability model in StatCrunch, which is the easiest thing to do. You're welcome to do it by hand. By hand, you would take 0.3 times 0, 0.4 times 1, 0.2 times 2, 0.1 times 3, and add them up. That's what gives you the mean. The standard deviation, harder to do by hand. You're welcome to do it, but again, I suggest using StatCrunch. So notice I found the mean and standard deviation in StatCrunch. Then I also found the variance, so it's not essential for you to go ahead and calculate the variance because you can just calculate it as you go in the upcoming questions. So let's look at number 2. If I select 3 residents, what are the mean and standard deviation for the number of calls of those 3 residents? So really what I'm saying is I'm taking x plus y plus z, or you might see that written as x1, x2, x3, because it's really the same random variable. So in this case, because they're all the same, I can just take 3 times the expected value. If I expect each one to call 1.1 times, then I expect 3 of them to call 3.3 times. No tricky math there. However, this one's the tricky one. Remember, if I have 3 of them, then I need to take my variance, which I've already calculated here, times 3. So if I hadn't calculated variance, this work would look like the square root of 3 times the standard deviation squared. So I had to square the standard deviation to get the variance. Then I'm going to take 3 of those, take the square root of that to find the standard deviation of the 3 residents. Same thing with the difference. This is the difference of 2 people, Ethel and Alta. And notice the expected value is going to be subtraction because I'm finding the difference.
but since we always add variances, notice here I'm adding the variance. So it's the same thing I did here. This time I did it with 3. This time I could have just put a 2 times 0.09 instead of adding them twice. It would have been the same thing, and I get 1.134. For the last one, there's a major storm and the citizens are now calling one more time a day. So essentially I'm saying before they called 1.1 times, and now they're going to call one more time a day, and so I expect that to be 1 greater than that. That is a measure of position. However, a measure of spread, like standard deviation, we talked about the fact that that would not change because everything has shifted up by 1, but the distance between them has not changed, so the standard deviation doesn't change. So here's another practice for us to do, and I wanted to throw this one in here because it's very similar to the one I assigned you from your MyStatLab homework. And again, this one is not a story problem. This is just straight up, do you understand the rules with random variables? So notice I've got x that has a mean of 20 and a standard deviation of 2, and I have y that has a mean of 45 and a standard deviation of 9. So those are the numbers I'm going to use. Now notice number 1 says find the expected value of 2y plus 2. Well, what I know about the expected value is that it is affected when I multiply, and it is affected when I add. So the expected value means that I would take that 45, which is the expected value of y, I'll multiply it by 2, and I'll add 2. So my expected value is 92. But looking at the standard deviation, we said, yes, this is going to be affected if I multiply it, because we looked at a few examples in that way. But does the 2 make a difference? No, it's not going to matter if I add anything to it. So notice the standard deviation is just me multiplying the standard deviation of 9 by 2 to get 18. So if you feel comfortable, go ahead and press pause and try the other questions yourself. Otherwise, stick with me. So same idea. This time now I'm looking at x and y. So again, what do I know about when I multiply expected values? That means I'm still going to be multiplying them. So if the expected value of x is 20, I'm going to take that times 4. The expected value of y is 45, I'm going to take that times 2. So my expected value is just adding those two expected values after I multiply them, and I get 170. Now the standard deviation, a little bit trickier because I can't just multiply the standard deviation because these numbers aren't the same. So I have to now look at the variances. So I am again using that strategy that said if I'm taking the variance of 4x, I got to move the 4 out here and make it 4 squared. If I'm taking the variance of 2y, I have to take the 2 out here and square it. So I'm taking 16 times the variance of x, and the variance of x is found by taking the standard deviation squared. And so notice I've taken 2 and squared it. And then the variance of y is the standard deviation of y and squared. So I'm taking 9 and I'm squaring it. And then I'm doing all of that work on the inside, adding those products together, then taking the square root, and I get 19.7. Last one. Remember, this is a difference of values, and when a difference of values with expected value means I'm going to take 2 times the expected value of y minus 3 times the expected value of x, just like I would expect to do based on the equation. However, when I'm looking at standard deviation, we never subtract, we always add, and so it's going to look a lot like this one, where I am finding the standard deviation by adding variances. So notice here, the 2y means I took the 2 out front, so 2 squared times the variance of y, which is the standard deviation of y squared. And then 3x means 3 squared times the variance of x, and that means the standard deviation of x squared. And incidentally, that's why these are being squared, because we had to move them from standard deviation to variance, or vice versa, sorry. And the standard deviation would be the 9 squared and the 2 squared. And so again, notice I'm adding, even though it says subtract, I always add variances, and therefore that is my new standard deviation.